Hi, we are Diego Montiel and Oliver Bravo, and we're going to present our video game, the Traffic Simulator, or the Lopez Mateos Simulator. The full color experience that helps us think towards new solutions against the large problem that city traffic is, now at a low price available in any popular OS where Golang can be installed. This program simulates a small portion of the city, where the number of cars and traffic lights can be adjusted, each one of them controlled by a different thread. Cars follow given routes, respecting the stop sign or color of the traffic light, cars ahead of them, and the direction of the road.
Now we're going to talk about the architecture of our project. First of all, our project is a multi-thread traffic simulator, and we use everything as the main model in order to render images and control the sprites. We use 3 different threads, one controlling the functionality of the cars, another for the traffic lights, and last, one for the game engine or game controller. This one is in charge of all the game functionality. For example, setting the number of cars, the number of traffic lights, and render the images in specific positions. Next, we're going to talk about the structs. We use 5 different structs in our project. One for the traffic lights, one for the cars, one for the routes, one for the traffic light controllers, and last, one for the game controller. Then, we can see the main flow of our project. First of all, we decide how many cars and traffic lights we're going to set. Then, we decide control options. For example, the position of our cars, the position of our traffic lights, and the routes if each car is going to follow. Next, we render the map or the layout. And finally, we start the simulation. Next, we're going to have a little tour in our project. We're going to focus on the most difficult parts or the most difficult problems we had to solve in order to finish our project. First of all, we can see the 5 main structs we use in our code. Then we can see the 3 threads we use, one for the cars, one for the traffic lights, and one for the game engine or main functionality. We call this game loop. The most difficult part was the car behavior, because we had to lower the speed of the cars in the back. For example, imagine we have 2 cars, one in the front and one in the back. The front car stops in a traffic light, so the car in the back has to lower its speed in order to avoid collisions. We did this by making a subtraction in the position of both of the cars, and if this distance was lower than 10 pixels, we lower the speed of the car in the back. And we use slips in order to avoid race condition and in order to make the correct thread running. Secondly, we have the function that draws the board or the city. This was very difficult because we had to make sure each different sprite or image renders in a specific position. For example, we have an image for straight parts, for turns, and a main intersection. It was very difficult because the positions were relative. The position in the top corner was different from the position in the bottom corner. So we had to use the height and the width of the screen as a compass in order to make sure we render the image in the correct position we needed. Lastly, we're going to talk about the initialization of our game engine and our main structs, the car, and the traffic light. Here, we can see initialization of our game engine. The default value of the number of cars is 7, and the default value of the number of traffic lights is also 7. Then, we initialize each car with the default values too. Here, we can see initialization of our cars. And in the end, we initialize our traffic lights with a random color, green for go and red from stop, like every traffic light works in the real life. Next, we're going to have a little demo of our project. First, we use the make test command in order to build and run our code. First, we can see a basic menu. We can select start game, change options, or exit. For example, if we select option number 2, we can change the number of cars, the number of traffic lights, or return to the main menu. Here we're going to return to the main menu, and we're going to start our simulation. We can see that each car starts in a random position. Now, my partner Diego is going to talk about the functionality of the routes and traffic lights.
Cars randomly select one of the given routes and follow through a set path from origin to destination as specified in the instruct. When the car arrives at its destination, an in-screen update on the top left of the screen informs us of this event. Each car only pays attention to the traffic lights that are set for that specific route, so it won't get confused when passing through intersections or any unwanted error happens. The functionality to stop at each light when it's red is made possible by setting an imaginary line or box before each light to emulate the time in which real-life drivers decide if they will stop or keep going depending on the state of the light.
Okay, now we're going to close this screen and see that if we close that screen, the simulation stops. We're going to run the same test, but with different parameters. For example, now we're going to set the number of traffic lights to 1. We can change this with the option number 2. We select 1 traffic light, and we're going to change the number of cars to 2, for example. Now we're going to return to the main menu and start the simulation again. As we can see, the map only renders 1 traffic light and the 2 cars we select. So we can change this in the main menu and make the simulation a little more specific or realistic. And last, we're going to talk about some key learnings or conclusions we have.
Some key learnings that I got for this project is the use of the Golang language, and more specifically, the use of the Go routines that help us code concurrently in order to apply sleep times in them to avoid problems such as race condition was.
A key learning of mine was the use of evidence or the use of images inside Golang, because you can't render images without a specific library or model in Golang. So everything uses matrices in order to render these images, and you can move them, rotate them, skew them, or make different operations in order to change these images. So I really like how the library works, and I really learned how to handle images and sprites inside Golang. Thank you for your time and consideration.